Good morning, everybody. I wish I could be there in person for this presentation, but due to current events, unfortunately, that wasn't meant to be. Nonetheless, let's talk about dashboard visualization techniques. My name is Kevin Feasel. I run a predictive analytics team out of Durham, North Carolina. I'm a Microsoft Data Platform MVP, and I have a blog called Curated SQL. The idea of Curated SQL is I try to find and link to 5 to 10 interesting posts per day on topics like database administration or development, R, Python, Hadoop, Spark, Scala, Power BI, or anything else in this broad data platform space. So that's curatedsql.com. Okay, here we are, main event. I have quite a bit to cover this morning, so I will jump right in, starting with dashboard basics. Dashboards are going to tell us about critical business or operational metrics. One of the most important things to me about a dashboard is that it display as a single pane of glass. What I mean by that is I don't have to click, drag, scroll, expand, contract, or otherwise manipulate your dashboard in order to see my data. The data that I want are key performance indicators, things that are important to the company, that are important to my team, to myself. I want these things bundled together in a logical format so I don't have to search all over the dashboard for them. And speaking of logical bundling, if you have multiple dashboards, I'd like to be able to see each dashboard have roughly the same theme or at least the same experience. The reasoning behind this is I don't want to have to retrain on every single dashboard and learn what the mechanics are of this one versus this other one. At the end of the day, I love this quotation from Stephen Few. Dashboards are not an appropriate venue for artistic impression. You can come up with something which is quite aesthetically pleasing, but unless it has a utilitarian value, it's not a good dashboard. Dashboards are ultimately utilitarian as opposed to artistic. There are 3 major sorts of dashboards that I want to cover today. The first one is operational dashboards. So operational dashboards give day-to-day data that assist line employees in making decisions. And when I say day-to-day, it could be real time, it could be a few minutes delayed, it could be 15, 20, 30 minutes delayed. But it's generally closer to real time. And these tend to be specific to your technical group using the dashboard. So this is an example of a dashboard that I created for my predictive analytics team. We launched an API, and I wanted to track number of requests. I wanted to track how quickly we were responding to these requests and see if there were major changes in data at different percentiles. So, for example, I have the 99.9th percentile of response time in milliseconds. I can see how that changes over time. I can slice it by endpoint. I can look at different time frames. This is quite useful to my team and to myself because we are regularly observing this dashboard to ensure that our service is running. Operational dashboards ultimately drive action. They will tell you whether a process is in control or out of control. So if you can see on this chart, the gray may be a little bit tough, but up here is about 4.3, down here is about negative 1.9. And what we have is a control chart. So this is actually called a control chart. And if you are within that gray boundary, your process is in control. If you exit that gray boundary, the process is now out of control. And that's why we see some red dots up here. If you see these red dots, that's an indicator something has gone wrong. Now we have to figure out what's happened and how can we fix it. Strategic dashboards, meanwhile, are on the other side of the spectrum. These focus on key performance indicators, generally are tracked periodically. So we refresh it every month, every quarter, and they display aggregates of information. So in this dashboard, we have up in the top corner back here, we've got some revenue, we've got number of new customers, we have revenue per customer, we have customer acquisition cost. It all adds up. We have collections of metrics that are in strategically placed locations, and they are at a monthly level or at a quarterly level. So this isn't the type of dashboard that you sit and watch over the course of a day. It's one that upper level management looks at when it comes time to rethink strategy. A tactical dashboard is sort of an in-between land. So they show strategic data, stuff that you may not look at every day, may not be updated every day, but at almost an operational level. So this is for the people who want to really dig into data. A strategic dashboard generally does not have filters, slicers, or other ways of affecting the screen. It is what it is, and that's it. A tactical dashboard is for people who have this urge to open up Excel with the data. This kind of gives them some of the pieces, but not the full Excel experience. Next up, I want to talk about a normal dashboard. This is, I would actually consider it a normal dashboard. It is probably in the 50th percentile. I think it's a bad dashboard. And in chat right now, tell me, what do you think of this? What are the problems with this dashboard? Normally, I would be able to ask people live and they'd give me some answers. And we'll come to these answers later on. But probably a few people have typed in something already, hopefully. So we can intuitively see that this is not really a good dashboard. But I want to take the rest of the time in this session to explain the reasons why, to give you an understanding of what makes for good dashboards, and then we'll come back to that normal dashboard. The first thing I need to talk about is knowledge. We have to learn about a few topics. So the most important thing to me about a dashboard is that it get an emotional response. A great dashboard evokes one of two emotions from your intended audience. Either your audience is really happy or they are really angry. If I look at this eye chart, I'm neither. I don't understand what it means. I don't understand. I guess there's, the red dots say, hey, something's out of control, but I'm not really sure what that represents. By contrast, if I am a line worker and this is perhaps the tolerance of the diameter of different holes that we're boring, and we see that, oh no, things have gone bad, this is a really bad sign. I need to take action. I'm angry because I have to act. So I've got to go stop this thing, fix this thing, bring it back to tolerance, and then I become happy because we're back in control. Everything's looking fine. So we evoke emotion because we can give an indication that here is a response I need you to make. And that's what a really good dashboard does. You can only do that if you know who your audience is. Who is going to look at this dashboard, how they're going to use it, what are the things that are important to them, and what kinds of actions would you like them to take as a result of seeing your data. Who your intended audience is really matters. If your intended audience is the general public, you may not be able to show them the same level of detail as a finance team or a technical specialist. So, as an example, if I show you my operational chart, a lot of people in the audience are probably technical people or business analysts or work in this space. Probably get what's going on here. If I show this to my team, they get it. They can see what's happening and they know, oh, I see this major spike. We should take action and determine why did this happen. If I show it to my boss, he'll look at it, he'll say, that's cool. Maybe he'll look at it on occasion just out of curiosity, but it probably won't come to mind very much. I show it to the VP. He'll say, oh, okay, that's great. He won't look at it again. He's got other things to look at. If he showed it to the COO, his boss, she looks at it, says, I don't really understand what this does for me, and never looks at it again. And in each one of those cases, the result is perfectly reasonable. This is a dashboard intended for line employees on a specific team to help them solve problems. As you take it out of that context, it becomes a lot less useful. So how will users make use of the dashboard? What do you want them to do? With that eye chart, the response is, hey, you're out of control. Go figure out what's happening with this machinery. With my endpoints, if I see response time spiking, we got to figure out, are we getting hit with too many requests? Do we perhaps need to add new servers? Is a server causing problems? We need to investigate the logs and see what is happening. Ideally, you as a dashboard creator will provide relevant metrics in a way that is easy for the audience to see what's happening. So, in order to give them this relevant information, think about whether you need historical data or just the present value. You need historical data. How far back? In my case, maybe I need a few days back just to give you an idea of what normal looks like. If you have rules or baselines that we always have to be within this range, this is our valid tolerance based on an SLA, based on a guideline, based on a contract, we can put that rule in place. We can also perhaps help determine when a user should act. For example, if we look at the machinery and say, well, I need to check the pressure and the temperature, and based on what those pressure and temperatures look like, this is the action to take. We might even be able to display those rules and say, hey, this is out of tolerance, the pressure looks like this, the temperature looks like this, the recommended action is tighten this screw, and it should solve the problem. So we may even be able to show that on the dashboard. Also, how will people look at your dashboard? If you have a 40-inch 4K screen just sitting right in front of you, then absolutely let's make a high density, high DPI Excel fest of a dashboard and let people have so much real estate to play with. That's great. But if I'm looking at it from a phone, that dashboard becomes terrible because now I have to pinch scroll and zoom and try to dive in to see any information. If I display it on a tablet, it's not that much better. If I display it on a television and we have to click, drag, scroll, or anything else, well, I don't have an easy way of changing anything on the TV, which means I don't want to click, drag, or scroll if I'm displaying it on that television. Are you showing the right measures? Are you showing them in the right way? So for a sales team, the response time for that dashboard might actually be a part of selling. That, yeah, we guarantee this percentile, or in this percentile, this response time. And perhaps that helps you make sales. But if you're showing a sales pipeline, that number doesn't matter. So if you're showing a sales pipeline, stick to measures that are relevant to the story of the sales pipeline. And this is a really quick Excel mockup. It's very ugly, but that's okay because it gets the relevant points across. We have different levels of a funnel, everything from we've emailed a group of people, they've responded back to us, we've engaged with them a bit and made them an offer, and eventually they agreed to the offer and we have a contract that's waiting for them to sign. Then we have the number of customers, the amount of revenue that might come from this, a probability of a success based on the level they're at, and therefore how much revenue we expect and what we would expect in this quarter. A sales manager could look at these values and, having some context around what a normal Q3 looks like, could say, oh, this is good, I'm going to bring this up in the next meeting with the C-levels, or this is really bad, we have to have a meeting right now to figure out how to fix this. Nowhere in here does SLA for a response time fit because this is for a sales pipeline. If people really want to try to fit it in, it's an indication that maybe there needs to be a separate dashboard. There needs to be a separate place for those other metrics. One last thing that I do want to touch on just a little bit is that cultural differences do matter. So for example, color can make a difference between different groups. In the European and American world, red typically means one of two things, love or danger. Depending on who you get married to, could be both. In finance, red is a negative value. It's a scary thing. You're in the red. By contrast, you go to China, red has historically meant prosperity. People give gifts of money in little red envelopes at weddings, at events, Chinese New Year. Now, interestingly, red still means that you're losing money in finance, but there is a difference in how we interpret red. It's a much sharper meaning, say, in America versus in China. Next thing I want to talk about is visual principles. 6 important visual principles, the first one of which is cognitive load. I should note that for each of these visual principles, the way that people figure this out is typically they take a bunch of undergraduate students from colleges, give them beer money, and have them fill out surveys. So take some of these with a grain of salt. Some of them have been more tested than others, but it's not necessarily a perfect guarantee that this is actually correct. But I think each one of these is at least reasonable. So cognitive load is the idea that our brains can only hold so many things at a time. And it's interpreted as we can hold about 3 to 7 items at a time. The original study was how many separate numbers can you remember, given to a bunch of college kids who needed beer money. But think of this like registers as in a computer. And our longer term memory is like RAM. We move info into and out of these registers, this extremely short term memory, and then move it into long term memory if we want to keep it, or we drop it out. You can only keep so many things in short term memory at a time. How this applies to us is that we want to reduce mental load. We want to reduce the number of possible things that could be coming into a person's mind as they look at our dashboard. There are a few ways to do this, and many of these techniques come from a German school of philosophy, the Gestalt or Form school. So this group, one of their key insights was that people will group like things together. And likeness could be size, shape, orientation, thickness, color, a few other attributes. But if you see a bunch of vertical lines and then one diagonal line, we immediately see the diagonal. If you see a bunch of red squares and then a blue square, immediately see the blue square. We see the differences. We also want to remove noise from the reader. So if there's something that does not help tell the story, get rid of it. So here's an example of something really terrible that I came up with. And I'm going to use my mouse for this. In the top left corner, we have our company logo, and above that, here the company title and the dashboard name. If you're talking about an internal dashboard, I hate this. I know what company I work for. I don't need a reminder that I work for my company. If you're talking about something external, then yes, you can keep a logo in. But if this is internal, get rid of the logo, get rid of the company name. Keep the dashboard name. Next, I have down here some indicator text that explains what this donut chart actually is doing and what this tree map actually is doing. Now, this indicator text is useful at most once, after which point it is not useful and it just takes up space. Ideally, we get rid of that text. Maybe move it off to a tooltip or something where if somebody needs to look at it, they can, and the rest of the time they don't have to look at it. So we could get rid of all of those. I wanted people to see this tree map first. So I dropped in all of these arrows to tell you to look at the tree map. If you ever feel the urge to put arrows to tell people where to look, you have too much clutter on the dashboard. It's time to get rid of some of that. So if we remove the arrows, remove the other clutter, so it looks a bit more like this. This is easier to read, but I still think we can make improvements. One example is remove the legend. So here's the problem with legends. I'm looking up and I say, okay, 2015 is down here. All right, great. 2016, there, okay. 2017, there. Wait, what color? What was this again? Our eyes move up and down as we look from the legend to the actual text. The problem is, eventually you just stop looking up and down. You give up. if we instead get rid of the legend and apply labels to the elements, now I don't have to look up and down. I can see immediately which one these years represent, what the colors represent. So if you have a detailed legend, it is an indication that you might be using the wrong visual. Also, reduce color usage. Here I have an example with a lot of different colors, and you may notice that, well, here's the state of Kentucky, here's the state of Ohio. They're the same color, so how are they related? You might think about it, you might come up with conjectures of how they could be related, but in reality, this is actually just the default Color BI palette when I created the dashboard. This provides just as much information as this. I don't need the extra colors. They didn't actually give me information. But this is better in one key regard, and that is I can tell you that there's one state that I want to talk about in more detail following them. I didn't have to point at the state. I didn't have to tell you the state. You immediately saw that because color is a pre-attentive attribute. You unconsciously see it before you recognize that you saw it. So as I switched from one color to one color plus a highlight, the highlight stood out. Even though there's not a huge contrast between these colors, it still worked. Also, color is an associative property. So what that means is people tend to link similar things together if they have the same color. So on the left-hand side, we have people who like the Bee Gees, and yes is blue, no is orange. Then I did something really evil. On the right-hand side, I flipped those colors. So now no is blue and yes is orange. But people look at these charts and they think, oh, well, these two, okay, yes is blue. All right, so must be yes is on the other side as well. Yes is blue. Because we naturally assume if you have two things that are right next to each other and they're shaped similarly and they behave, then they would behave similarly. We don't expect major changes in behavior. So try not to give major changes in behavior because that means that people can be wrong. They can misinterpret what you're doing. Also, humans have a lot of trouble with precision in 3D. Especially when you're taking a 3D or you're trying to do a 3D projection in a 2D space. So in some rare cases, 3D images are better. There are places in physics, in geology, certain sciences, where having that third dimension really helps explain things, like in topographical maps. But it is never the case for column charts that 3D actually helps. 3D only hurts. In this case, I may ask which is bigger, A or C, and it's actually really tough to tell. I may even ask, what is the value of A? People would look at this. I've done this in person quite a few times, and they'll give me anything from 0.3 to about 0.35. And in Excel, the tricky thing is that you think of it as a camera that is looking overhead and pointing at the screen, and what the projection back to this back wall would look like, that is actually the line. So it's not this blue line at the top, the dark line. It's not this blue line here. It's actually something that's a little bit higher than that because of the way it projects. It's just a very weird setup. Don't do 3D. Does not help at all in getting your point across. It just hurts. So where do we look? In European languages, we typically will read left to right, top to bottom. In Hebrew and Arabic, we read right to left, top to bottom. In ancient Asian languages, ancient Chinese, ancient Japanese, especially, top to bottom, right to left. Modern Chinese, left to right, top to bottom. Modern Japanese, left to right, top to bottom, except when it's top to bottom, right to left, except when it's top to bottom, left to right. And this advertisement that I have right up here actually hits all three of them at once. So I can't explain the rules behind it, but they have rules, I guess. So this drives where we look. This sort of behavior drives where we look. uh, assuming that we're talking about native English speakers or native German, native Spanish, some European language, left to right, top to bottom, our reading layout is that we start in the top left corner and then our eyes kind of move diagonally downward until we get to the bottom. So we start in the primary optical area. We're kind of looking with a focus over here. And that means, by the way, if you want to hide information, you kind of hide it down here and people are least likely to see it. So that was the original idea, the Gutenberg layout. Now the Z layout, they say, well, it's not quite like that because you don't really glaze over like a triangle. Instead, you start by reading straight across, but then you kind of cut back because you want to get this thing over with and you read across at the bottom for the conclusion. So if you want to hide information, you generally hide it around here. Now, there's a third layout that comes from Jacob Nielsen. Jacob Nielsen took some people and showed them articles from the Washington Post. What he noticed when tracking eye movement was that people started out reading the whole line, but then as you go further down, they read part of the line, but don't get quite to the end and just kind of glaze down and down until you get to the bottom stem of an F where it's just straight down, I'm done with this article. Interestingly, one of the things he found was anything which breaks up the monotony of the text resets a person's brain and they go back to reading the whole thing. So this is actually why they put interstitial advertisements in the middle of newspaper articles online. So that way it kind of resets your brain and you start reading across again. So all three of these layouts are interesting, but I think they don't quite apply to us as dashboard designers. And here's why. They are intended for evenly distributed, homogeneous data, like newspaper articles that are text heavy. Well, if your dashboards are like newspaper articles, they may not be very good. We have generally image heavy dashboards, and so we're going to follow a different principle, focal points. The idea behind focal points is that I can focus in on specific areas. So here I have an example of a photographic concept, bokeh, where I am focusing heavily on one level, one depth, to the exclusion of other depths. And that applies to dashboards as well, where if I show you just an arbitrary dashboard, you're going to look at things that are large, colorful, and in certain positions. So here we see the tree map at the bottom. We see the column chart on the right. Interestingly, sometimes when I show this, people don't even see that there is a drop-down box with a city-state. The contrast isn't very high, and it kind of falls back behind everything else. So we want to point people toward focal points and have relevant measures around those focal points. The next topic I want to talk about is the rule of thirds. So the rule of thirds comes from photography and from art. The idea is that you take an image, whether that be a photograph, a painting, or whatever, you can slice it into thirds, vertically and horizontally, and the intersections of those slices are the points where people naturally focus when they're looking at that image. So we will look at one of those 4 points, naturally. So you want to put your subject on at least one of those 4 points. And in this case, the bottle is our subject. It is aligned to 2 of the 4 points. You might think we want to put it directly smack dab in the middle, but our eyes actually don't want to look in the middle. It's interesting how it works. Also, a bonus tip. If you are a landscape photographer, generally the horizon is going to be either the top line or the bottom line here. So you'll either have, like in this case, the horizon is at the top and you have sort of a lot of land or water. Or you may have the horizon over here and you have a lot of sky. Generally, if your horizon is way off of those two, the picture just looks weird. So going back to our strategic dashboard, if I slap on some big ugly lines, the dashboard kind of follows the rule of thirds. The first image is pretty close to where I would want it to be. Shift it a little bit over. We could do better, but it's kind of okay. The rest of the images, I'd want to move them a bit, because I would actually like those images to be on the rule of the thirds. That way we can go from image to image, and our eyes just naturally flit across to those other images. We can have the text around it, the measures around it, maybe put them in slightly different locations to support having this layout. But I think it works better than the way that the current dashboard is designed. So glanceability. This is the idea that a human can, with just a glance, get important information from your dashboard. I love the irony that this is actually my least glanceable slide. So things that help with glanceability. You have to be able to show clear purpose in your metric design. Things are laid out as they should be. You've grouped metrics together into sections. You're not making people search top left corner, bottom right corner, and somewhere in the middle for your 3 revenue measures. They're all together in a revenue measures section. There is no scrolling. You should never have to scroll on a dashboard, especially a strategic dashboard, because this dashboard might be used on a television. It might be used on a phone or a tablet where I don't necessarily have a desire to do a lot of scrolling. I just want to see the numbers. I need to have large fonts, rounded numbers to make it easier for me to read. For financial reports, we want exact figures down to the penny. For dashboards, they don't have to be that. They could be rounded to millions of dollars, hundreds of thousands of dollars, hundreds of dollars, whatever rounded number fits best, just have it rounded there, and that way it's easier for people to read it quickly. $7.8 million is easy to understand, even if the proper value is actually $7,798,644.12. Unless that matters, the rounded number is easier, more glanceable. Also, color vision deficiency, something I want to bring up. This affects roughly 8% of men, roughly 1/2 of 1% of women. There are 3 key varieties of color vision deficiency: protanomaly and protanopia, deuteranomaly and deuteranopia, tritanomaly, tritanopia. So the first set is where you have a deficiency in red cones. Second set, green cones. Third set, blue cones. The protanomaly and deuteranomaly combo, so those 4, is the large majority, and people colloquially refer to this as red-green colorblind. Here's the reason why. This is the Badlands, as seen by a drone, the drone that I flew. We have a mix of colors. We have reds, yellows, greens. We have a little bit of darker colors, grays, and blacks. If you have protanopia, this is what it looks like for you. The red is gone. The green is muted. So coming back, we have green that gets muted into yellows and oranges, and the red is gone. If you have deuteranopia, the red, so things tint actually a little bit more red. Yellows come out a bit stronger, but again, the image is pretty similar. It is tough to see that colored splotch where the sandstone is. If you have tritanopia, then the green is gone altogether. We can see the red very clearly, but now the grass is hard to differentiate. We've lost a lot of coloring shade. So remember SSIS 2008, where you had green for success, red for failure? Well, if you have tritanopia, this is what it looks like for you. It's still pretty easy to differentiate. If you have protanopia, what it looks like for you. Actually not that easy to differentiate. If you have deuteranopia, it's even a little harder to differentiate. So it becomes very difficult to tell success versus failure. And that's why in SSIS 2012, Microsoft made it easier for everybody by getting rid of all indications of whether a job failed. So, possible solutions for color vision deficiency. Use color-safe palettes. There are palettes that are designed that anybody from pure monochromatic, you cannot see any colors at all, to full color vision can differentiate. Use grayscale for images, which actually helps out if they're going to be printed. If you don't need color, don't use color. Use it as a point of emphasis. So if you have just one main color, like let's say you pick black. Black is your main color, and then you use red as an offset color. That would work fine. That offset color, maybe you only use it for emphasis. You only use it for the currently selected item or the thing I want to show you. That combination can work. Or a gray and red, or gray and blue. You also want to use a website like Coblis to simulate various forms of color vision deficiency. I actually simulated all of those images using Coblis so that you could see what it looks like for somebody who has a particular form of color vision deficiency. It's a really cool link. I'll give it to you at the end as well. Let's talk a little bit about types of visuals. And in this section, we'll talk about any of the visuals on this chart. The first is just a simple table. It's easy to forget that tables and matrices are visuals. If you need to simply compare numbers, this can be an effective technique. I don't put these on strategic dashboards. I generally will put them on a tactical dashboard. Sometimes I'll put them on an operational dashboard. But strategic, usually there's a better way of showing the data. Column charts are really good when you have a few categories but several periods. So here I have 13 episodes of a show, and I'm showing 3 different series, 3 different shows, and the number of critic reviews. By contrast, bar charts are good when you have, say, one period of time, but many categories. Also, if your labels are lengthy, bar charts are better. With a column chart, you'll notice that my label was very short, episode 1, EP.1. That's because I hate 90-degree text, by which I mean, say, English text where it's written top to bottom or bottom to top, because what that means is you have to tilt your head like this, and then as you're walking with your phone with your head tilted, you bang your head into a wall. It's just not a good experience for anyone. So don't do that. Don't tilt your text. People read left to right, top to bottom for English. So bar chart, really good because I can lay it out left to right. Don't have to tilt my head. Regardless of whether you're using a bar or a column chart, please make sure they start at the origin. The reason is, if you look at this, a lot of people will look at this chart and say, oh wow, that first estimate is like a third of the second estimate. That was a really big difference. Some number of people will look at this and say, wait, you went from 0.6 to 0.7. That's actually not much of a change. And if I laid this out on the origin, you would see it's a minor change. It's a 16% change versus 3x, 300%. It's a huge difference in terms of how we experience it. So bar column charts always start at the origin. Now, if you don't want to start at the origin, a Cleveland dot plot is a viable option because it's just a good way of comparing categories. I don't have to start at 0. I can start here at 7 or whatever the value is, but you can still compare and see which shows are considered better than the others. Radar charts are something that I admit that I have a soft spot in my heart for, but you don't really want to use them. Not very often, at least. Normalized comparison of measures across several categories. Where I fell in love with them was actually playing Madden NFL. They had these ways of scouting players, and I would spend hours just going up and down trying to figure out if that strength was just a little bit higher for this guy than the other guy before I draft them. So that's why I love radar charts. Not because they're that useful. They're useful sometimes, just not a lot. Line charts, very useful. Time series data, stretching over many periods with non-cyclical data. But, important thing, you only show a few categories. You only have a few independent things you're looking at. Here I have 2. 2 is fine. 2 is really easy. 3 is okay. Once you get past about 4 or 5, you start stretching what you can display on the screen. You start getting into spaghetti, and that's just not good for anybody. You can combine a line chart and a column chart if you have 2 interrelated but distinct variables. So for example, this is the number of votes and the rating by episode of The Punisher. You'll also see this with stock market, the stock price at different times of the day, as well as the volume of shares sold. So for line charts, we said bar and column charts start from the origin at 0. But for line charts and dot plots, I showed you cases where we don't start at 0. Hopping back to this last graph, on the left-hand side, we have 0 as our starting point for the bar chart. On the right-hand side, we have approximately 8 as the starting point for my line chart. There's no strong advice on exactly where the charts begin for line charts. Cleveland, McGill, and McGill had a paper that they proposed that your average line slope should be about 45 degrees. Other researchers came back and said, well, that's just like your opinion. So there's no strong evidence or strong reasoning around how these line charts should be laid out. And thus, I'm okay taking whatever the product comes up with. So whatever Power BI, Excel, Tableau, whatever that product shows, usually I'm okay with it. I may change it just a little bit to maybe I want to include a cutoff point, a minimum or a maximum. But the thing is that if you expand it too far, all lines look flat. If you tighten in too much, you may lose information. Scatter plots, 2 variables, small number of categories. So here I have number of votes, number of critic reviews. And we can see that they're clusters. We can see the black and the blue spots cluster together pretty well. The red ones live off on their own. Bubble charts add a 3rd dimension. So that's great. It gives me even more information. In this case, number of user reviews. But the problem is, it is now hard to understand what's going on in this chart. It's hard to see where things fit together, or like in the red dots, where the individual points actually are. Tree maps, again, it's a thing that I like, but they're not that useful. They're good in one really important case. Large number of hierarchical categorical values that you drill in through. So here I have states and cities, or countries and cities, and I can drill through that for important information. Very briefly, a few charts I don't like. Pie charts. Don't like them. Their best use is simple share of a static total, but here's the problem. Angle differences, hard to discern. If you have small percentage differences, it's really hard to differentiate. Like, I can ask you, is A or C bigger? Is B or D bigger? And I'll bet you half of you will be wrong. Half of you will probably be right. Half of you will be wrong. Pie charts usually require legends. So you had to look down and see what A and C were, what B and D were, because it wasn't obvious. By contrast, if I show you a column chart, you can immediately see, oh, yeah, B is actually larger than D, and A is slightly larger than C. You can immediately see what those values look like. So column charts are good if you have a few categories. Tree maps are good if you have a lot of categories. As you get more categories, that pie chart gets crammed with little tiny slices. It's just not going to fit. Simple numbers, just show the number. There's no reason not simply to show a number. Now, in fairness, a couple of pie charts I like. This one shows that knowing is half of the battle, but it also shows what the rest of the battle is, in case you grew up with G.I. Joe and you never knew that. Also, pie I have eaten, and the pie I will eat after this talk. Gauges. Progress toward a target 4% full. They're useful. If you think about a fuel gauge, how much fuel do I have left? Very useful. It shows me where I'm at, how much I have left. In this case, 50 looks like it must be some sort of target. I don't know if I need to get up to there or down to there, but whatever. The problem with gauges is that if you don't have a goal, an expectation of what normal looks like and where you need to be, they don't tell you much. Like this case is a gauge that shows 34 out of 68. Now, why 68? Is that some sort of cap? Well, no, actually in Power BI, you don't have a target or a limit. They just take twice the current value and that becomes your end value. So it puts you in the middle. Well, that's not helping me very much. It doesn't provide me any information. Stacked area charts will show you two things with certainty. Number one, what is the total value of all things? Number two, what is the value of this thing? Everything else in between, hard to tell. If you need to know those in-between values, it's actually better just to show the lines themselves. So that way you can see how each thing operates independently, as opposed to seeing how they combine together. Ribbon charts will show you rank changes. So they'll see that, Punisher had the fewest critic reviews in episode 1, but then it swapped in episode 2, and since then it had the second most for the rest of the runs of each show. But they tend to be noisy. It's a lot of extra color, it's a lot of extra pizzazz, and it's only useful if you can mouse over the data point. That's when they give you a lot of helpful info. Otherwise, it's just a lot of noise. A lot of visual fluff for nothing. So in the last couple of minutes, I want to take another look at that normal dashboard. See what we can find out. So here's that normal dashboard again. Now, looking at this, the first problem that I have is, of course, pie charts. I don't like them at all. I don't think they're helpful in this case, especially because these pies have so many different slices that it's hard to tell what they actually represent. There are too many colors. Some of these colors overlap to the point where, depending on how good your screen is, you may not even differentiate some of them. There is some unnecessary 3D chrome that was added on to make it look nice. Doesn't add any value. Actually, doesn't take too much value away in this case, but it could. It doesn't help any. There's category overload. Each one of these things has just too many categories. And actually the bottom one, incidents by category, notice the ... down here, notice all the ... here. I can't even see what the categories represent in many of these cases. There are just too many of them, and it doesn't fit. Scroll bars. I have to scroll up and down to see things. And even worse, for the middle one, incident trends and their status, notice that this starts with the earliest time period. Generally, I'm most interested in the latest time period, which means I constantly have to scroll to see that data. That's not a good experience. There is color reuse. I see blue, blue, blue. I assume all of those blues mean the same thing. They absolutely don't. Now, fortunately, in this case, they don't mean it's not a color shift where attributing cause is inattention to detail, and then down in root cause, inattention to detail is something else. So at least they don't reuse categories with different colors. But reusing color gives us the impression that these things are related, that these things are tied together when they're not. There is this unnecessary chrome. If you're on a desktop, this isn't so big of a deal, but it does take up extra space. Ideally, you'd want a product that hides it until you need it. Power BI does a pretty good job of that. They will automatically hide Chrome until you mouse over the section, and then it'll show you your options. So wrapping things up, a few tips to keep in mind when creating a dashboard. Use the appropriate visuals. Colors are a signal. Use them consistently. Get rid of unnecessary Chrome, unnecessary chart junk, things that detract from the experience. They don't help tell the story. Avoid legends if you can, as well as scroll bars. Those will help make your dashboard glanceable. Get rid of that stuff. Makes it easier to read. White space is your friend. You don't have to fill every segment of a dashboard. You can have some negative space. And please ensure your dashboard is CVD friendly. Go to a website like Coblis, upload it, check it out with different setups, and make sure that everybody can read it. If you'd like to learn more, go to csmore.info/on/dashboards. And for any additional assistance or questions or comments, feel free to reach out to me. Email address, Twitter handle are right here. With that, I'd like to say thank you so much. Have a wonderful rest of your day.